morning, pupils. It's nice to have you one more time. We're having a class today, and we'll be looking at square root of non-perfect square. Before then, previously we have discussed square root of perfect numbers, and if you recall, it was a very easy way. I gave you square root of 4. You just look for two numbers to multiply, that will give you 4, and then you get this perfect square, and that one of these will be your answer. So this was what we discussed previously. But this time around, we are looking at non-perfect square. We are looking at numbers that are not perfect square, that you cannot easily get their square roots. The square root will not give you a whole number or an integer. Now I have so many acronyms here that I want to explain what they stand for. Now NPS here means non-perfect square. So this means non-perfect square. This refers to numbers like 5, 6, 3, numbers whose square root will not give us a whole number. Now here we have NLPS. This represents next lower perfect square. Alright, so I'm going to use all these to explain how you can find the square root of a number that is not a perfect square. Sometimes you get engaged in solving some questions and you are locked up. When you get to a step like this and you feel this is the final answer, you can actually get something closer. Now, to evaluate the square root of 5 is very simple. The first thing you write is to think about the next lower perfect square. Now, if you recall all your perfect squares, just like squaring the natural numbers, if you square 1, you get 1, 2, you get 4. So those numbers you are getting are your perfect squares. Now, the next lower perfect square to 5 is 4, because 2 times 2 gives you 4. So that will be my next lower perfect square. So I'm putting that as 4. And this 5 is our non-perfect square. Yeah, so I have all the 2 requirements to get the answer. Now, to evaluate square root of 5, I start all over again. It will be, if you go by the formula, the square root of the next lower perfect square, that will be 4. Right. Now, the next is plus. Then I have my non-perfect square. I'm following the formula now. The non-perfect square is the question, is the question that we are given. That's the 5. Right. Minus the next lower perfect square, we got it previously. I told you that's 4. Then we are dividing this part. Please be careful. This line of division does not cut across 4. It ends here. So we are divided by 2 multiplied by the square root of the next lower perfect square, which is 4. We have this. So all we have left is just to solve. Right? The square root of 4 is 2. Plus 5 minus 4 gives us 1. Right, if you divide this, you have 2 times the square root of 4 once again is 2. So what I'm having here is 2 plus 1 over 4. Now if you add up this one, this will give you 2 whole number, 1 over 4. Right, definitely if you punch your calculator, most calculators will give you this answer in decimal numbers. So we'll be writing this one in decimal figure. Right, so therefore the final answer, square root of 5, will give us 2.25, because 1 over 4, if you take 1 over 4 using your long division, right, to a decimal figure, you get 0.25. But before this, I would like to tell you what happened between here and the final answer. Now, if you come to this corner, how did I arrive at that 2.25? It's just changing this one to decimal. I can break this up to 2 plus 1 over 4. You remember this? Now, so using our long division method, I can keep this here. If I keep this out there, we go ahead with our division. So 4 in 1 is 0, which is impossible. So if I multiply this by 4, I have 0. If you subtract this one, you have 1. So I can put a decimal point here so that I can have as many zeros as I want. Right? So if I put a 0 here, 4 in 10 gives me 2. So 2 times 4 gives me 8. If you subtract this again, you have 2. Right? Since you already had decimal points, you can add as many zeros as many times as you want it. So if I'm adding another 0 here, so 4 in 20 gives me 5, and then 5 times 4 gives me 20. At this point, I have a remainder of 0, so there is nothing to do. anymore. So if I take back what I have written here, it's the same thing as 2 plus, so my 1/4 has been changed to 0.25, right? You know, this is a simple addition. This is the whole number. If I want to write this one to two decimal places, in two decimal places, it's going to be 2.00. This is the whole number, so it has to stay with the whole number. And then this is 25. If I add up this, it will give me a total of, this is 5, 2, and then 2. So that was how I arrived at my final answer, 2.25. You know, we can do a checkup. Now, if you punch your calculator, using your calculator, if you punch the square root of 5, it's going to give you 2.23. So what am I saying from here? This is just like, our answer is going to be like an approximate of what, right, a kind of approximation of what you're supposed to have in the actual answer when you get, but something very close to it. Maybe a plus or minus 0.3 will be the difference between, or the addition of, difference between the two answers, the actual square root of 5 using calculator, and then the one you're going to get using the method that I have explained to you. Now we have a work example, a practice exercise, which we are going to do together. I want us to follow. Don't forget our acronyms. What did I say NPS represents? Alright, I think we are saying it rightly. That's non-perfect square. I hope you can still recall that. Now, what did I call NLPS? Okay, that's very correct. That is next lower perfect squares. So these are the only two things I see I need. If you look at what I've done here, you see it's still here, next lower perfect square, now non-perfect square. Next, so I'm not doing anything. The bulk of what you are seeing here are just made up of two things: the non-perfect square and the next lower perfect square. So now let's look at these examples as we solve together. Now, what will you call this 10? If you recall from the first example, this 10 will be my non-perfect square. That is 10. Alright, now how do I generate my next lower perfect square? I'm talking about a perfect square that is lower and next to 10. What would that be? Should that be 4? Do I still have another perfect square after 4? Yes, I have 9. And if I pick 9 as my next lower perfect square, the next perfect square after 9 is going to be what? 16. 16 is greater than, that's why I stated here, it has to be lower. It has to be next lower. So it can't be more than the non-perfect square. It has to be less. So that's why I'm choosing 9 as my next lower perfect square. I hope that is very clear. So now let's go with the formula. So square root of 10 will be equals to, what am I writing here first? Square root of the next lower perfect square. That will be square root of what? 9. That is very correct. Now it's going to be plus, what is the first thing I'm writing? Next non-perfect square. That's very correct. And that is 10 minus, the next thing there is the next lower perfect square. Correct. That's it. That's 9. So all divided by 2 multiplied by what we here, the next lower perfect square. That is very fine. So let's solve what we have here. Square root of 9, that is 3 times 3, that's square root of 3 times 3. Same thing as 3. So this gives us 3 plus 10 minus 9, that gives us 1. Divided by 2 times square root of 9 is what? 3. That's correct. So if we solve this further, we have 3 plus 1 over 6. Right? Now, if you do a quick one with this one, this is the same thing as 3 whole number. This is the same thing as 3 whole number 1 over 6. Right? If you want to write this in decimal, we can change. Okay, sometimes you can leave your answer as fraction, but I'll prefer you leave it as decimal, because if you point your calculator, it's going to give you this answer in decimal. So this answer will be 3 whole number 1 over 6, or 3 point what? What did you get? That will be 3.16. Now let's do a quick check on this. If you punch your calculator, what do you get as the square root of 10? What do you have? Very lucky. We have exact answer, 3.16. You see, sometimes it can be very close, very, very close, and sometimes it can be very exact, just like we have in the practice exercises. Alright, I hope this is very clear to everybody. It's just two things you need. Non-perfect square, the next lower perfect square. With those two, you can get the square root of any non-perfect square number, right? And we have the following exercises I want you to try your hands on. They are very simple. Remember, this is the square root of 7. Can somebody tell me what the next lower perfect square will be? What did you get? 4. Very correct. Thank you very much. And for this one, you need the next lower perfect square. What would that be? 16. That is very correct. Thank you. For 17, 16. For 15,
9.
you got 9. For 37, 36. So with this, you don't have any problem solving this question. I hope you've enjoyed this class, and I want to enjoy all of us to please keep safe, stay connected, and stay blessed. See you next class.